Hello everyone, it's lecture 4 from iTunes Academy, Binomial Infinite Series. Here in case 2, the power n of the binomial expression less than 1. So n can be fraction or negative number. Okay, and if we have that, we have infinite series. Okay, 1 plus x power n. Don't forget this n less than 1. So we will have infinite series. Okay, let's expand this bracket. The first term here is n combination 0, 1 by n negative 1 plus 1, and here x power 0 as we did before, plus n combination 1, here 1 power n negative 2, and here plus 1, x power 1 plus n combination 2, here 1 minus 3 plus 1, x 2 plus n combination 3, 1, 4 plus 1, here we have cubic x. This will be infinite series. Okay, so number of terms here will be equal to infinity, and here if you notice that the first term in this expression must be 1, so the first term must be equal to 1. And if I have, for example, a plus b x power n, this will be converted to a power n, here 1 plus b by a x power n. We take a as a common from this bracket. Okay, and here the values of x here of the substitution are limited. So we have here condition of conversion. Okay, here absolute of second term, which here represented by x, must be less than 1. Okay, let's clear that and move to first example. First example here, need to find first 4 terms of the expansion of 1 by 1 plus 3 x squared power 2. Okay, so as we did before, we have here plus 3x squared power negative 2. So n here less than 1. We are here in case 2. Okay, this will be equal to, we have here n equal to negative 2, so negative 2 combination 0. Here we have 3x squared 0 plus negative 2 combination 1. Here 3x squared power 1 plus negative 2 combination 2 3x squared of 2 plus negative 2 combination 3 3x squared power 3 plus this infinite exponential. Okay, we have here negative 2 combination 0, so this will be 1 plus, we have here negative 2 combination 1, n combination 1 equal to n, so we have here negative 2 n2 3x squared plus negative 2 combination 2, so n combination 2 is n into n minus 1 by factorial of 2. So we have here negative 2 into negative 3 by factorial of 2 into x squared 3 squared plus, we have here negative 2 combination 3, so as we did before, negative 3 into negative 4 by factorial of 3 into cubic x, here cubic 3 plus infinite series. So we have here 1 minus 6x squared. Here we have 9, and here we have 3. So plus 27x squared. Here we have negative 4, and here 27. So here we have 108 cubic x plus infinite series. Okay, our solution isn't complete. Must write the condition of convergence. Here we have absolute of the second term. Second term is 3x squared less than 1. So we have here 3 absolute x squared less than 1. Here 1 by 3. So x, or the available values to substitute with x, here we have absolute x less than square root of 1 by 3. Okay, so only the available values of x is between negative square root of 1 by 3 to square root 1 by 3. Okay, let's move to second example. Just clear that. We have here square root of 2 minus x. So here 2 minus x power half. Here we have the first term isn't 1, so we will take square root 2 is common, so we have here 1 minus x by 2 and that power half, and here equal to half. First term here is n combination 0, so half combination 0. Here we have negative x by 2 0 plus half combination 1 x 2 1 plus half combination 2 x square plus half combination 3, and here I2 power 3 plus the completion of infinite series. So we have here 1 plus here we have half into negative x by 2 plus here we have n combination 2, so here half into n minus 1 here is negative half by factorial of 2 into here we have x squared by 4 plus here we have n combination 3 as we did before, half into negative half into negative 3 by 2 by factorial of 3 into cubic x by 8. Okay, this equal to 1 minus x by 4 minus here we have x squared by 32. Here we have minus 3 this with this, so 3 by 384 cubic x and the completion of the infinite series. Just write the condition of convergence. Here we have x 2 less than 1, so sorry, that's absolute, so absolute of x less than 2. So the domain of x values between -2 up to 2. Okay, let's move to we have some special series of case 2. So the first special case here, or the first series, is the series of 1 by 1 x is equal to 1 plus x squared plus cubic x plus and here another one, 1 by 1 plus x is equal to 1 minus x plus x squared minus cubic x plus the compilation of the series. Third, 1 by 1 minus x squared equal to 1 plus 2x plus 3x squared plus 4 cubic x. Here 1 by 1 plus x squared equal to 1 plus, sorry, here we have minus 2x plus 3x squared minus 4 cubic x plus the combination. So here this series can be used directly in our example. Okay, so let's just clear this here and complete our example. Another example here, 1 by 1 plus 4x this square. So we have here 1 plus 4x negative 2, and here is negative 2. So the expansion of this is negative 2 combination 0. Here 4x power 0 plus negative 2 combination 1, 4x power 1 plus negative 2 combination 2, 4x power 2 plus negative 2 combination 3, and here 4x power 3 plus the combination. Okay, so we have here 1 plus, here we have negative 2 into 4x plus negative 2 into negative 3 n into n minus 1 by factorial of 2, this by 4 square x square plus here negative 2 into negative 3 into negative 4 is by factorial of 3 into cubic 4 cubic x plus the completion. So here we have 1 minus 8x. Here we have this into this plus 48 x squared. Here we have minus 256 x power 3 plus our completion. Okay, and don't forget the condition of convergence. Okay, here we have 4x less than 1, so absolute x less than 1 by 4. Okay, here we expand this expansion of the binomial Okay, but we can solve this by alternative way. If we look here, this expression is similar to this plus expression. So let me write this here. You have 1 plus 1 plus x squared is equal to 1 minus 2x plus 3x squared minus 4 cubic x plus. Okay, here we don't have x, y, we have 4x. So just in this expansion, replace x by 4x. So we have here 1 minus 2 into 4x plus 3 4x square minus 4, and this is cubic plus. Okay, here we have 1 minus 8x plus 48x square minus 256 cubic x plus the completion of our series. So just you can use this special series to find this expansion. Okay, let's move to our next example here. Find first four terms of the expansion of, we have here 3 plus 2x squared by square root of 1 plus 2x. Okay, so we have here 3 plus 2x squared into 1 plus 2x. This is our negative half. Okay, so just we will deal with that as this. Here we can expand this bracket. 9 plus 12x plus 4x squared into, and this is infinite here, so we can expand this as that. Here we have negative half combination 0, here 2x power 0 plus here combination 1 into 2x 1 plus combination 2 2x power 2 plus combination 3 2x power 3 plus our completion. Okay, so just write this plus x plus 4x squared into, here we have 1 plus negative half into 2x plus negative half into negative 3 by 2 by factorial of 2 into 2x squared plus negative half into negative 3 by 2 into negative 5 by 2 by factorial of 3 into 2x power 3 plus completion. Okay, just rewrite this here into 1 minus x Here we have 3, we have here 4, and here 3 by 8. So we have here plus 3 by 4. We have here x squared. Here minus, here we have this will be 8. So we have here 5 by 8 cubic x plus our completion. So just multiply this bracket into this series and obtain our first 4 terms. So let's do that. Just clear and rewrite this here. This equal to 9 plus x plus 4x squared into 1 minus x plus x squared minus 5 by 8 cubic x plus our completion. So here just multiply 9 by this series plus 12x into this series plus 4x squared into this series. Okay, so equal to 9x plus 27 by 4 x squared minus 45 by 8 cubic x plus, okay, this plus, if we multiply 12x into this series, so we have here 12x here, 12x squared, here we have 9 cubic x plus, if we multiply for x squared into this series, so we have here 4x squared, and here we have 4 cubic x. So the final result here is this equal to 9 plus 3x minus 5 by 4 x squared plus 51 by 8 cubic x plus the completion. So this is our expansion, and here is the first 4 terms of the expansion here, but we miss the condition of conversion. Here we have 2x absolute 2x less than 1, so absolute x less than half. Okay, let's move to another example. just clear that. Another example on this case, we have here square root of 1 minus 3x by 1 plus 2x. Okay, so we have here 1 minus 3x power half into 1 plus 2x negative 1. Okay, so the first series here equal to here we have n equal to half, so half combination 0. We have here negative 3x 0 plus half combination 1 into negative 3x power 1 plus half combination 2 into negative 3x square plus half combination 3 here negative 3x power 3 plus our completion. Okay, so we have here 1 and here we have 3 by 2 x, or sorry, negative 3 by 2, as we have here negative 3x into n combination 1 equal to n, so this equal to half. We have here negative. Okay, here we have plus half into negative half by factorial of 2 into 3 square x square plus here we have half by negative half by 3 by 2 by factorial of 3 into negative 3 power 3 here cubic x plus our completion. This equal to 1 3 by 2 x here negative 9 by 8 x square, and here this equal to this 27. This is 3 by 48, so this 1 by 16. Here we have 27 by 16 cubic x plus completion. Okay, so this is the first binomial expression. Move to second. We have here 1 plus 2x negative 1. This is similar to this second series, but we have here 2x, so just rewrite this in same sequence. So we have here 1 minus here plus here square minus here cubic plus our completion. So here we have just replace x by 2x, so we have here 2x 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 equal to 1 minus 2x plus 4x squared minus 8 cubic x plus completion. Okay, so just multiply this series into this series. Okay, just rewrite that. Okay, so in the first expansion, we don't have to write four terms because we need only to find three terms. Okay, so the first expansion equal to 1 minus 3 by 2x minus 9 by 8 x squared plus completion into here we have 1 minus 2x plus 4x squared plus completion. Okay, so we have here just multiply 1 by this series, then negative 3 by 2x by this series, and negative 9 by 8 x squared by this. So we have here 1 x plus 4x squared, this plus multiply this second term. So we have here 3 by 2x, and here we have second term, we have plus 3x squared plus we have here negative 9 by 8 x squared plus the completion. So here we have the final result is 1 7 by 2 x plus 47 by 8 x squared plus. So here is our expansion and the first three terms in this expansion. Okay, find the coefficient of x power n in the expansion of, here we have 1 minus x by 1 plus x z squared. Okay, so we have here x squared into 1 plus x squared. So we have here one of our special series here, this series. So just expand this bracket here into this series. So we have here 1 minus 2x plus x squared, and here we have this, just write it here. So 1 minus 2x plus 3x squared minus 4 cubic x plus completion. Here just multiply 1 negative 2x and x squared into this series. Okay, so we have here 1 minus 2x plus 3x squared minus 4x plus 3 plus multiply negative 2x into this here. So we have here negative 2x here, 4x squared here. We have 6 cubic x completion, this plus multiply x squared. So we have here x squared and here negative, sorry, negative 2 cubic x plus the completion. So we have here 1 minus 4x plus 8x squared minus 12 cubic x. Okay, so here if we have to find the coefficient of x power n. So here just look here first to the sign of all terms. So we have here in the odd power of x we have here negative sign. So here first write what's referred to your sign in this series. So we have here negative 1 power n. As we find the odd power of n here has negative sign. Okay, and move to the number. Here we find the number here related to the power. So just here negative 1 power n into 4 n. Here we find the power 2 multiplied by 8 and power 3 multiplied by 12. So this is of x power n. And here our condition of convergence. Here we have absolute of x less than 1. So the domain of x, or the available values of the substitution of x, is between negative 1 and 1. Okay, let's move to next example. Again, find the coefficient of x power n and the expansion of. Here we have 2 minus gx by here 1 minus 3x minus 4x squared. Okay, so just we have here 2 minus 3x by here just factorize the denominator. Here we find 1 minus 4x into 1 plus x. Okay, this equal to here from partial fraction lecture we write these factors here 1 minus 4x and here 1 plus x. Easily we can find this constant here by direct method as we know before, because we have here two different linear factor. So here we have here a, b, and by using direct method we find a equal to 1 and also b equal to 1. Okay, so we have here this binomial expression and here binomial expression. If we take that, this is similar as this special series. Okay, just replace x by 4x. So let's write this formula here: 1 plus square here plus 3. Okay, and here let's replace x by 4x. Here plus this. We have here special series. Just try it. The expansion of this 1 minus x plus x squared minus cubic x plus. By adding this expansion to this, we can find the final expansion of these binomial expressions. But here we need to find the coefficient of x power n. So this will be equal to the coefficient of power n from here plus the coefficient of power n from here. So let's start from here. We find this. Just first look at the sign. Here we have all positive sign. So let's move to number here. If we look here, the number is related to the power n of every term here, and the base is 4. So here, from here, we find the coefficient of x power n is 4 power n. And from here, plus, let's look first at the sign. So we have here at the odd power negative sign. So just write this -1 power n, and all the number here is 1. So this is multiplied by 1 power n. So this 1 here, the final result here 4 power n plus -1 power n, and this is the coefficient of x power n. The coefficient of power n, x power n. Okay, and here let's find the condition of conversion. From the first expression, we find that condition of conversion is absolute of 4x less than 1. So here x less than 1 quarter. Okay, and for a second expression, x, absolute x less than 1. So here we have to take the intersection between two. So let's write this x less than 4 and x absolute x less than 1. So here we have to take the intersection between these conditions. Here the result is absolute x less than 1/4. Okay, I hope this point clear, and let's move to another different example. Find len 2 based on the expansion of len 1 plus x by 1 minus x. Okay, okay. So here f of x equal to len 1 plus x by 1 minus x. This can be converted to a subtract. Okay, so here this equal to len 1 plus x minus len 1 minus x. Okay, so this is a function of x. Here we want to get rid of this len, so just take the derivative of this function. So here derivative of f of x by x, so here f dash of x equal to derivative of len x is 1 by x, so here we find plus x, here 1 by 1 minus x into the derivative of this bracket, so here we have negative 1. Here we find 1 by 1 plus x plus 1 by 1 minus x. Okay, and here is two special series, so just write it here, f dash of x equal to, just write it, 1 minus x plus x squared minus cubic x plus this plus 1 plus x squared plus cubic x plus just adding this to this, so we can find the odd power here will be eliminated together here and here. Okay, so here we find 1 plus x squared plus x power 4 plus x power 6. Okay, okay, and take 2 as a common, okay, from this expansion. Okay, so here we have here f of f dash of x. To obtain f of x again, we will take the integral of this function. So f of x here equal to 2. Here the integration of 1 is x plus integration of x squared is cubic x by 3. Here plus x power 5 by 5 plus x power 7 by 7 plus the completion. Okay, so here we find the expansion of this len. Okay, but we missed something here. By here take integration of this function. Here must add constant of the integration. Okay, and to find this constant, just clear all of that. We just are sure as x is a common value in all condition of conversion x equal to 0. Okay, as we take absolute x just less than 1. Okay, so 0 is in this domain or condition. So just rewrite this function again. X plus cubic x by 3 plus x power 5 by 5 plus x power 7 by 7 plus, okay, and this plus constant of integration. To find this constant, just substitute with s x equal to 0, okay, in both sides. Here f of x, if we substitute with 0, so we have here len 1 equal to 0 plus constant. Here len 1 equal to 0, so our constant here c equal to 0. So the constant of integration equal to 0. Okay, let's rewrite this here and find just constant equal to 0 here and find len 2 from this expansion. Okay, so len 2 here equal to len 1 plus x by 1 minus x. So just take the exponential of both sides. So here 2 equal to here 2 equal to 1 plus x by 1 minus x. So here 2 minus 2x equal to 1 plus x. From here x equal to 1 by 3. So if I need to calculate len x from this expansion, just substitute with x equal to 1 by 3, but there is something missed here. We must make sure with the condition of convergence. Here x, absolute x less than 1. So x equal to 1 by 3 in between our domain boundaries. So you can substitute with x equal to 1 by 3. So len 2 here equal to, from this expansion here, plus 3 power 3 power 3 plus power 5 by 5 plus power 7 by 7. And this is len 2 based on the expansion of this expression len 1 plus x by 1 minus x. I hope this point clear. You must make sure is x value in between the domain boundaries of the condition of convergence, okay, to substitute with it, okay. I hope that clear, and thank you.